Projectiles. Projectiles. Okay, opening. Alright, write this down. Projectiles. Okay, got that? Yeah. Projectiles. Right. So what is a projectile? A projectile is an object that travels through space with only gravity acting on it. That's the only force is gravity. Generally travels along a parabolic path, which we'll have a look at the picture in a second. So in other words, a projectile is anything traveling through space and the only force is gravity. This is a projectile. So if you can write this definition down, you really only need this part as the definition. Does anybody know this word? Parabolic? This shape.
Yep.
Where have you seen this in maths class?
Parabolic. Quadratic.
Yes, that's what it is. Yeah, quadratics. Yeah. Okay. Write that down, please. Right. Okay, you got that, you're right. Got that? Yeah. So this is what a parabolic path looks like. It has this x squared shape to it. In fact, it will be exactly like a quadratic, this minus x squared. So you can imagine it being like a quadratic here. So this is a projectile. Once the bicycle, has left the ground, it then has no control over its motion. The only force is gravity. True, there's friction, but we don't consider the friction. So, once this bicycle is in the air, the only force is gravity. That's the only force. Okay. Does that make sense? The only force here is gravity. Yeah?
But what's pulling it that way? There needs to be a force pulling it that way.
There does not. Because what's happening is its velocity here is carrying it to the left. Yeah, look. Huh? What do you mean now? You don't believe me, or you don't agree? You're not convinced? If I throw this at you, what is carrying it to you? There's no force on it, is there?
The force from your hand.
Yeah, but my hand is no longer touching it.
But it gave it like a push.
Yeah, but it's not the force that carries it, but it's its velocity.
Oh.
Yes? Yeah. Okay. It will travel this parabolic path as shown. Okay. So this is not a projectile. Why not?
There's a force acting on keeping it in a space.
That's it, yeah. So projectiles have only gravity acting on it. That's all. No other force. He travels wherever he wants. Okay. Right. So a couple of important points about motion in two dimensions, x and y. So you'll need to write these down. Firstly, the dimensions, that means x and y. are independent. So what does that mean if I say the x and the y are independent?
There's a dimension, like to the horizontal and to the vertical. There's a velocity to the horizontal and one to the
They don't
vertical.
interfere with you.
No.
There's a resultant force.
You can stop there. What does it mean if they're independent? The x and the y are independent?
They don't interfere with you, with each other.
Yeah, so what it means is no matter what happens on the x, it does not affect the y. So the x could be doing anything, it has no effect on the y. So they're separate problems. They do not interact, they're separate, x and y. So you should make note of this. The first point is they're independent. Okay, you have that? Next, gravity is only on the y-axis. So gravity goes on the y, nothing on the x. Gravity is only on the y. So if gravity is on the y, it means the force is on the y, which means there's no force on the x, which means there's no acceleration in the x.
I'm sorry, could you repeat that?
Yeah, there's gravity's in the y, which means there's force in the y. No force in the x, which means no acceleration in the x. So the x-axis has no acceleration.
So if we go back to the example, he was not accelerating.
He was not accelerating horizontally, only vertically. And we'll see this, we'll explain this more in an example. The acceleration was only vertical, not horizontal.
I have a question.
Yes.
If there is no gravity,
Yes.
and then when we project,
It will travel in a straight line.
yes,
Yeah.
the velocity will not be affected unless we...
Yes. It'll stay constant.
So, then let's say if we go to space and then we throw something.
Yeah. It will continue. Yeah. Yeah. At the same speed.
This is theoretically, or in space there are no particles, so it will go and non-stop. Or are there particles in space?
There's not, but I mean, it'll continue in a straight line until it hits something.
So
Now, space is very big, and there's not many things in it, so it could be a very, very long time. Yeah.
So, like, let's say a rocket is launched from here to the moon. Like, halfway, they would just switch off the engines and they would continue straight.
Not exactly halfway, but there is a point where the engines could be switched off and it could still reach there, and that's actually something we'll calculate in semester 2. Yeah. Okay, next. You can use vectors to resolve projectiles into x and y. Do you remember resolving vectors? So we have a cos and a sine. Yeah. Okay, I'll just give you a second to write that down. So next, when we're looking at projectiles at their maximum height, next. So projectiles have no vertical speed at their maximum height. So when the projectile reaches the top, has no vertical speed on the top. Again, I'll explain all this with an example. And remember, I said it once and I'll say it again, S is position, not distance. And I'll say that one more time because it's really important. For example, a ball that's kicked along a field will have Sy equals 0 at the end of the flight. So if you picture the ball here, and it gets kicked up in the air, and then it comes back down, what's its height at the end? 0. That's what I mean here. So the S vertically, increase, maximum, decrease, and down to 0. Again, once we have an example, it'll be a little bit clearer. So if I go to the notes here. So let's say here's the ground. And I'll just to make things a little bit clearer, I'll just put a wall here. And then here's the projectile here. And it goes up, reaches as a maximum, and then comes back down like this. This is how I picture it. I always imagine there's two lasers on the projectile. There's two little lights. One horizontal, one vertical, horizontal, vertical, like this. So if you picture it like there's a light here and a light at the side. So if you were to look at the ground, what would you see on the ground? You'd see a little red dot, and what would happen? Moving. Across like this. Can you picture like the little red dot on the ground moving across? Can you visualize that? Yeah. So that's what I mean by the horizontal. That's the horizontal part. That does not affect the height. It's just on the ground. Yeah. And how would you picture this moving? Would it be slow? Would it be fast? Would it be slow at the start, fast at the end? What do you think?
It would start off
You picture fast or slow here?
fast.
So it's going fast, and then what happens?
Slows down.
Slows down here, and it's slowest here,
Yeah.
and then what happens?
And then it starts speeding up.
And then it's fastest here?
Yeah.
No.
Same speed.
Uh,
Keep on slowing down.
Sorry about that. That's what I did, yeah. I wanted to see where you were going with this.
I thought you were going to give him a Nobel Prize.
No. It's the same speed because I said in the slides there is no acceleration in the x. No acceleration means constant speed. Means this moves along at the same speed. Yes? Now you see, now you'll remember it now next time, yeah? Now what about on the wall? What happens? You see a red dot, it gets higher, but then what starts to happen?
Slows down.
Slows down until it stops, and then it starts to fall back down again. So this is the x and this is the y. So imagine when the ball is here, this is the sx, the distance it travels horizontally, and then here is the sy. In other words, you can take a projectile and turn it into two UVATS problems. One in the horizontal and one in the vertical. Do you get what I'm saying here with this? Yes? Yeah. So let's see, do I have an example to do? Yeah. Okay, write this example down. This is the first one we'll do. Have you got the information? Can I do it? Yep.
Yep.
Yes? Okay. So, let me draw this for you. Here's the ground. and the projectile is fired at 30 degrees at 100 meters per second. The first thing I need to do is calculate the horizontal and calculate the vertical. Is this one the cos or the sine? Cos. 100 cos 30, and this one here, 100 sine 30. So 100 cos 30 is 86.6, thank you. And then the other one's 50?
50, yeah.
Got that so far? Does anyone know what this means? Time of flight?
Yeah.
Are you sure you don't? Alright. Time of flight? What's time of flight?
Total time.
Time from the beginning
Yeah.
until the end. Should we look at the horizontal or the vertical to get this information?
They both have the same time.
They do, but only one of them will give us that time. The vertical. There's, yeah, there's not enough information in the horizontal. The vertical will. So let's look at the vertical. This is vertical, Y. U, V, A, T, S. What's the U vertically? 50. The V?
We don't know.
No. The A we do know.
Minus.
T is what we want, and the S is what?
Maximum time.
No.
Zero.
Huh? Nope.
Zero. Wouldn't
Zero.
Wouldn't V be 52?
It'd be minus 50 actually, yeah. Yes?
Can I just ask?
Yes.
What if you find the distance from between the ground and the maximum height, and then find the time?
Yeah, I have a student like you in my other physics class who was saying the same thing, and I'll tell you the same thing. Don't do it this way. It's longer. Just don't do it this way. Just do it this way. Yes, you could find the time from here to here, and then the time from here to here.
Just double it.
Or just double it, but life is short, so just do it this way. Can you understand why it's zero? Because at the end, vertically, it's back at the ground. So it's actually displacement is zero. Vertically, displace zero. Okay, so what formula will give me T here? S equals UT plus a half a T squared. 0 equals 50T minus 4.905 T squared. 0 equals T. 50 minus 4.905 T. So you have two answers here. Which answers do we take, the first or the second? Yeah, why not the first? Yeah, so that can't be the total time. So you have 50 minus 4.905 T equals 0. So then T will be?
10.2.
Yeah, it should be about 10, shouldn't it? So 10.2? 10.2 seconds is the first part done. Okay, so if we can write this one down, and then we'll look at the next part. Next part. The next part is, what is the range? Does anyone know this word? Yeah, the range is the distance horizontally. This is called the range. The distance from here to here. That's the range. So, should we look at the horizontal or should we look at the vertical? Horizontal, of course. Now, the great news is, horizontally, is there acceleration? No. So you can use this distance, speed, time triangle. And what do we want? Distance. So what does distance equal? Speed multiply time. Do we know the speed? Yes, we do. What is it? And do we know the time? Yes, we do. So we can easily get the range. 883 meters. That's part B. Now part C. Time or maximum height? Maximum height. Vertical now, yeah. So for the last part we want the maximum height. So that's this height here. Horizontal or vertical? What should we look at? Vertical. Yeah, question?
Why is the speed 86?
That is 100 cos 30, the horizontal. Vertical. U-V-A-T-S. The U? 50.
Yeah.
V?
Don't know.
Oh, we do. 0. A minus 9.81. T we don't know.
We kind of do.
Kind of do, but we don't really. And we can work it out by dividing by 2. Yeah. The S is what we want. So what formula should I use here? Now the reason I'm not using the T is because if this was an exam question, if you made a mistake in the T, then your error carries into the next part. So we'll try and avoid, that's why I'm avoiding using it. What formula will give me the S here?
V squared.
Yeah. V squared equals U squared plus 2AS. So S equals 127 meters. So that's the maximum height. H here. Okay. Not super difficult, right? It's just really more UVATS problems. We'll look at another example now, if you can write this one down. Got this? Continue? Yes? Okay. Right. So again, if you want you can write it down or you can draw the picture with the information in it. So I'll just give you a minute to do that. I had to think of something interesting. I was getting tired of footballs being kicked or rocks being thrown.
Yeah, and then started with the stone and ended with the ball.
What?
Started with the stone and ended with the
Did
ball.
it? Where's the ball? Oh, the ball. Okay, yeah, I'll change that. Well, I'll fix that in a bit. Okay, can you draw the information? Which one? The angle is 60 and the speed is 25. So 60 and 25. No, it's up 60. Yeah. Projectiles, we always measure the angle on the ground. Okay. Right, let's have a look at this. Okay, 25 away. Okay, so let's try and draw this. Okay, so what we have here, right, what's the speed of the stone at the beginning? 25. And the angle? 60. So this is 25 meters per second, and the angle here is 60. And we also know how far away, don't we?
Yeah.
25 meters. And we also know that this distance here is 1 meter. And it will go up and then down, or something like this. And what am I looking for here? What's the time of flight and what height on the building? Yeah, so I'm looking for the time to get here and the height is what I want to know. So firstly, let's work out the x and the y. So this is 25 cos 60.
12.5.
Say again?
12.5.
12.5. And then vertically?
21.6.
25 sine 60. And what is it?
21.6.
No?
7. 6.5.
So 7.
So what are we looking for? Maximum height?
First the time. Okay. So, how can I get the time? Horizontally or vertically? Horizontally. Because we have the information horizontally here. We know that it travels 25. It's a triangle, distance, speed, time. Distance, speed, time. So, distance is what? And speed? 12.5. So if I want the time, that's distance over speed, which equals 2 seconds here. That's part A. And part B, I want the height. So where should I look now? Vertically. U, V, A, T, S. The U? 21.7. The V we don't know. A is minus 9.81. T? 2. S is what we want. S equals U T a half A T squared. What's that? .78 meters. Is that the answer? No, what is it?
24.78. Add 1.
Add 1. And the reason is this is the displacement vertically. So it's the distance here compared to the start. So we have to add an extra 1 meter to the answer to make it the right answer. Okay, write this one down, please. Yep. Am I missing one person or not? This is everybody? For the moment.
No, I was with the pharmacy group.
Is that the newest student?
Yep.
Yeah, okay. Can I go to the next example? Yeah. Okay, I think, yeah, this is my last example. So again, if you want to write the information down or draw it, and then I'll do it. I doubt you'll watch this movie, or have even heard of it. What's a cliff? I'll tell you what a cliff is. Right.
What movie is
Oh, maybe I should have done Fast and Furious then, yeah. This is a cliff. It's close enough. So what's happening here is the car drives off the cliff like this. Yeah? Okay.
If you want to drive off a cliff, it'd be faster than 15.
But I don't think in the movie they're on a road. I think they're on like a dirt path or something, like a field.
This is an actual movie?
This is I didn't make this up.
That's not Lewis?
Yes.
What year was it?
Oh, it's a long time ago, but it's a famous movie scene anyways.
So what's the movie called?
I think it's called Thelma and Louise. I think that's it. Well, I've just ruined the ending for you though. Okay, so the cliff is 400 meters high and they're traveling at 36 meters per second, and this is 400 meters high. And of course, this is what happened here. Right, first question, what is the time of flight? Horizontal or vertical? What are we looking at here? Vertical. So part A, U-V-A-T-S. Now think for 1 second before you say it. What's the U?
Zero.
0. Why 0?
Because you can't resolve vertically.
Well, there is no vertical at the beginning. There's only horizontal. This is like a 0 here. The V we don't know, the A we do know, the T we don't know, and the S we do know. What's the S? What is the S? Minus 400. Because it's going down. And we want the T, so what formula could I use? I'll just use good old S equals UT plus a half A T squared. So T works out to be 9.03 seconds when you solve it. Okay. Part B. What is the range? Okay, so what should I look at for the range? Horizontal or vertical? Horizontal. The range is the distance, and distance is speed multiplied by time. What's the speed? 36, and the time is 9.03. So this comes out to be 325 meters. That's the horizontal here. Okay, part C. What was the velocity of the car at impact? Now, if you think about it, as it's moving through the air, it will have a horizontal and a vertical velocity. And at the very end, it also has a horizontal and a vertical velocity. And I want to know what the horizontal and the vertical is. So I'll call this Vx, and I'll call the other one here Vy. In fact, you already know what the Vx is. What is it? 36. Why? It doesn't change. It's a constant. So we only need to look at the vertical to work out the Vy. UVATS. The U? 0. The V is what we want. The A is minus 9.81. The T we know, 9.03, and the S we know. So what's the easiest formula to give us the V? V equals U plus A T. So why is this number negative? Why is it not positive? It's going down, isn't it? Yeah. So what you have is, at impact, it's travelling 36 meters per second to the right, and it's descending at 88.6 meters per second down. It's not this that will kill the passengers, it's this one that kills the passengers. Not the horizontal, the vertical. Yeah.
You have to watch the movie.
Yeah, yeah. Well, you know, it's off the cliff. Okay. And actually, in my picture, I have them crashing in the ocean, but it's crashing onto the ground in the movie, so that's quite fast to be hitting the ground. 88.6. And how many kilometers per hour is that? Let's not test it. Okay. And lastly, anybody got any ideas for part D? Is what's the speed when it hits the water? The speed. Now remember, this is the velocity. Total distance over total time, true, but we don't know the total distance.
Yeah.
Yes. Remember, no, it's the magnitude. The magnitude. The resultant, yeah. So the speed, the actual speed of the car when it hits the water is square root 88.6 squared plus 36 squared. Yes. Yeah. Okay, hang on. And then okay, you got that one? Oh, sorry, what's wrong with my answer? Yeah. Yeah.
Could I see the question? Sorry.
There is another way to calculate the speed, which we'll learn about a little bit later. In fact, it's a little bit easier than this way. But this would be like an exam question, you know, where they might have it in parts, like this.
What is the What is the
Using conservation of energy.
Oh,
Okay, can I continue? Yes. Do you have this? Yes. Okay. So I think what we'll do, what we could do. Okay, I'll give you two choices. So the choices are, you can either do these all at once and I'll do the answers, or we can alternate. So you try number one, I do the answer, try number two, I do the answer. Which would you feel?
First option.
First option? Second option? Well, what do we want? Do we want...
Second option, you'll work less. First option, you'll understand more.
Yeah.
Ignore him for a moment. I feel like taking turns would be best for maximum understanding. I think so. Yeah. So the first ones are quite short, and I think what we'll do is we'll do 1 to 5 now and leave 6 for our homework. And it should only take you like 3 or 4 minutes to do each one, especially the first ones, they're quite short. So we'll go through these. When you have it finished, let me know and then I'll give you the answers. Okay, so if you can just do number 1 now. Let me just save something here. Well, actually, you can write down the question, then I'll save it. Okay, did you write the question down? It's 50 at 50. I want the height and the range. Got it, Omar? That's okay, it's here too. Okay, how are we doing with the first one here? Who's finished the first one? Finished? Omar? How's it going, the first one? Not good or not done? Not yet. If you're finished the first one, you can start the second one because I'm going to do that as well. I'll give you, how much more time do you need for the first one? I'll give you 2. Because I'm so generous.
Question.
Yes.
Horizontal speed
Hmm.
stays the same.
Hmm. That is all? End of question?
Yeah, but if we use v squared equals u squared plus 2as.
Horizontally?
Yeah,
Mm-hmm.
they're trying to find s.
Mm-hmm. It's no good because the a is 0.
Yeah.
So you can't use that formula.
So we have to find t.
Yep. Or distance, speed, time triangle. Almost like you weren't listening to me when I was doing the examples. Now, I didn't say you weren't listening to me.
No,
I said almost
yeah,
like.
We never use the triangle. We always found everything and then got everything.
Oh, life is short. So long. Okay, I think that is more than enough time for the first one. So let's have a look at number 1.
We have to find the time dimension.
Let's see it. Okay, so what's the speed? 50.
Yeah.
And the angle? 50. So, what was 50 cos 50, please?
22.14.
22.14?
Yep.
50 cos 50?
And 50 sine 50?
38.3.
50 sine 50 is 38.3.
I got 32.1 for cos. For cos.
And for cos, yeah, 50 cos 50, 32. Who told me 22? That was you, wasn't it?
Huh?
Yes. Indeed. 32.14.
I didn't write this in my notebook
But why did you say 22?
because that's what I wrote in my notebook.
Right. What do I want first here? Maximum height and range. So I don't know. We'll go with the time first. Before we can work out the range, we need time. Because if you look at the vertical, U, V, A, T, S, the U is 38.3. The V, we don't know. The A is minus 9.81. The T we don't know. And the S is 0. This can give me the time. As soon as I know the time, I could work out the range.
They want the maximum height.
And the maximum height, I'll do that separately then. Well, I'll do the maximum height up here. U, V, A, T, S. Let's do that first then. U, 38.3. V, 0. A, minus 9.81. And the S is what we want. V squared equals U squared plus 2A S. So S equals 74.8 meters. So the maximum height is 74.8 meters. Now I want the range next. Yeah?
Why doesn't it work when the acceleration is not positive?
Because it's not positive, it's negative.
Am I like? Should I like? I'm the one who's determining whether the like going up is positive or
Correct. So what did you say the U was? 38.3?
Oh no,
No matter, you said it was positive, correct? Which way is it going, up or down?
Up.
And you use the positive. So you're saying up is positive. Agreed? So therefore, acceleration down to Earth is a...
Yeah.
Now it all makes sense.
Yeah.
Yep. Okay, can we look at now the range? So here, what formula could I use? S equals U t plus a half a t squared. We get two answers for t, 0 or t equals. What type of equation is this? Yes, indeed. Which we've done in maths class, haven't we? Yeah, so no problem. 0 or 7.81 seconds. And then finally, to get the range, what formula could we use? We're looking at the horizontal. No, try again. Distance equals
Speed times time.
there we go, yes. So 32.14 multiply 7.81 equals 251 meters. What's wrong? Not fighting. What? Everything good? Any questions on this one? Omar, what's wrong? Are you talking about calculator? Just buy this one. This one. This one. This one. Yeah. Okay. Right. Try number 2 now if you haven't done it. Got it finished?
2?
Yes. Finish though. And double check your numbers. Just in case. At launch, meaning the speed at the start is 20. What's wrong? I know you have a question. Which word?
Bat.
Bat. B-A-T. That's it. Baseball bat, you know?
Not football.
It's not football, but it doesn't really matter if it was a football or a baseball. It's still done the same way. Okay. How's number 2 going? Okay. So I think the switching between trying and seeing is probably the correct choice. Yeah.
I was thinking on number 1.
Yes, yeah. This is what I thought. Do you want me to draw the diagram? Would that help?
Yeah.
So it's 100 meters, 30 and 20. Okay. So I'll just draw it and then you can continue it. What's happening in number 2 is you have a cliff, and how high do I say it is? It's 100, is it? And then here at the top of the cliff, something is launched at 20 meters per second, and the angle 30 degrees. So it's a horizontal and a vertical. And what do I want? The time. The time it takes to get from launch Sorry, I just have one word for you here. Right, so we want the time to get from here to here. Okay, does the diagram help?
Yeah.
Yep, okay. No, just the time.
What are you saying?
The time. Yeah, from here to here.
Only the time?
Yes. Is that what I asked for? Just the time? Yeah. You have an answer?
Yeah.
Who else has a time? Got a time? The time. The T. Yep. Anyone else have a T? Omar? How is it definitely wrong? Is it negative?
Oh no, like
What?
92 seconds. 2 positive.
Yeah.
Yeah.
What time did you get? Seems believable. Fuang, what time did you get?
5.65.
Yeah, I got 5.6.
I retract my previous statement. Okay, let's have a look at that now. So, in fact, we only need to look at the vertical. U, V, A, T, S. The U is 20 sine 30,
10.
which works out to be 10. The V we don't know, and the A is minus 9.81. The T is what we want, and the S.
Negative 100.
Okay, so once again, it's going to be S equals U, T, a half A, T squared, or in other words, 4.905 T squared minus 10T minus 100 equals 0. This will give me two answers.
One is negative and one is 5 point.
Yeah, one should be negative and one should be positive.
Negative 3.6 and 5.65.
So we accept this answer and then reject this answer. Can anybody tell me what this answer means? Because it does have a meaning. Why did the formula give me this answer? Because there is a reason for this answer. It does actually make sense.
The time it takes to get back to the same.
Reach the mark.
No.
No, not the maximum. it's from
Oh,
this and goes down.
Yeah?
So when it's here,
That's the time.
Almost. Well, on my diagram, what are you saying?
up. Yes. No. Yes.
At same level as the, like 100 meters above the ground.
Well, this is at this level.
the level where I was shot from.
And why is it minus though?
Like in quadratics, you have two answers. If you have two answers, then it crosses the x-axis at two points. So, if you go down, just go to the ground level. Down,
Where?
Yeah, here. So that's the 3.2 or 6.
But what does the minus mean?
It's like the other way.
Opposite what?
Opposite the 5.65.
No, without using numbers, describe the meaning of the minus here in the diagram, in the situation. The t is minus 3.61. That means
Going backwards.
we're getting closer. We're getting closer, but not this.
Is it it goes at this and
No.
Instead of going upwards in that direction, if it went the other way, it would take 3.61 seconds to reach the ground.
Closer, but still, what's the deal with the minus?
okay, we
Yeah,
don't know.
going the other way.
No, I want to see how far we can get. I'll tell you. So, what's happening here is, you start here, and you're saying 5.65 seconds in the future, the ball will be at a height of minus 100. 3.61 seconds in the past, it was at a height of minus 100. As if it was fired from here. The equation doesn't know there's a cliff here. It thinks simply it was fired here. 3.61 seconds in the past. That's what the meaning is.
Makes so much sense.
When I say it, yes. Okay. Right, try number 3 now. So I'll draw that for you to help. It's 44 out of 40 and it's 0.9 above the ground. So this distance here is 0.9 meters and it's launched at 44 meters per second. And this angle here is 40 degrees. And of course it will travel up and come back down. And I want to know this distance here. Finished? Finished? If you're finished, why don't you help your friends? Oh, are they not your friends? Yes?
I help them.
Yeah? Yes?
Who helps them eat
Very wise, yes. They must learn for themselves. Yes. Here,
Yeah.
no chance. I'll give you a little hint, okay? First you should get the time, then you can get the range.
We only have two.
For the vertical,
For the UVTA, yeah.
vertically,
Yeah.
no, you have 3.
Oh. We do 0.
Who's finished this one? Nearly?
Yeah. Give me 10 seconds.
What's the U?
28.
Very good, 28.28. The V, oh yeah, 0.3, whatever. V, we don't know. A, minus 9.81. T, we don't know. And S,
No.
Minus 9.8.
minus 0.9.
0.9.
What are you saying? Yes. Okay, and we can use our formula
Why is it minus?
because it starts here. So at the end, it's 0.9 below where it started.
Well, I'm still calculating the distance of...
Starts here,
Mm.
and I want the time it takes to get here, which is 0.9 below where it started.
So the upper part is irrelevant?
I don't care what happens here, I just need to know the UVATS from the start to the end. What happens in between I don't care about. Yeah. S equals U T plus a half A T squared. So this is a quadratic. It will have two answers. One of them will be negative and one will be positive. That's the positive, yeah. That's not quite finished because we still need to get the range. So horizontally, distance is... What's the distance horizontally, the formula? Speed multiplied time, which is 44 cos 40, whatever that is, multiply 33 point something, is it? 5.8. I'll just put it in at once.
195.55.
Let me double check. 195 meters is the final answer. Yeah. Why what? Why 44 cos? Yeah. So So what happens here, 44 cos is the horizontal and 44 sine is the vertical, and we want the range.
So why we not use 44?
44, yeah? 44.
No, just 44.
Ah, but 44 is this one, and we need this one, horizontal. No, you don't seem happy. This here is 44. This is the one I want, 44 cos 40, because it's in the x. And this one I used earlier, 44 sine 40, because it's in the y. Because, Fuan, we're looking for the distance in the x, the horizontal distance. Yeah. So 195 is the answer here.
So did we get it? Oh, okay.
Yeah. Yeah.
But in the last example, we use BTS, we not use.
Ah, but we used 20 sine 30, not 20. Yes, yes. And same here. Okay. Okay, write that down if you need to, or check your answer, and we'll have a look at the next one. You got this one? Yes.
What's our next topic?
After projectiles?
Yeah.
Let's have a look. After projectiles is something. Newton's three laws.
Aren't we doing them already?
We've only done one of his laws.
Oh,
F equals ma.
yeah.
Okay, try number 4.
Still existing.
Which word?
What happened?
Yeah.
Very good job.
It's slang, you know. I'm watching a football match. And I also noticed I had some mistake here. Okay, so I'll fix that later. You're watching so this one is 50 and 45. So I'll draw it here for you. What's happening in this one?
Maximum range.
Yeah, at 45 it is. So the ball is kicked. You know the angle is 45, but you don't know the speed. And it travels a distance of 50 meters. And I want to know the U. So I want to know this here. Okay, so try this one now. What's this one? 4, isn't it? So I'll give you a little hint here. This one is still u cos 45, which works out to be u over root 2. And this one is u sine 45, which works out to be u over root 2 as well. But that's not a surprise because it's 45, so they should be the same. You should still do it the same way. You should still first get the time and then look at the range. So the first thing you should do still is get the time.
Can you go back to the question?
Yes, but I think all the information is in the picture.
Do we not need 3 to get anything?
You have everything there you need, trust me. Okay, you ready to see this one?
Yes.
Did anyone get an answer? So this is, I've given up.
Before
Yeah.
we start. Do we use simultaneous equations?
Kind of. It requires something like this. So vertically, U, V, A, T, S. U is what? Vertically. U over root 2. V we don't know. A minus 9.81. T we don't know. And S 0. S equals U, T. No 0? Vertically.
Oh, okay.
S equals UT plus a half A T squared. 0 equals T bracket U over root 2 minus 4.905 T. So U over root 2 equals 4.905 T. So then T equals U over 4.905 root 2. But we know horizontally the distance is 50. So if I use my triangle distance, speed, time, what does distance equal? Speed multiplied by time. So the distance is 50. It equals the speed. What's the speed horizontally? U over root 2. Multiply the time, and what's the time? Well, there it is there. U over 4.905 root 2. So 50 equals U squared over 4.905 times 2. Can you figure out the U from this? Yeah, because there's only one unknown. So 50 times 4.905 times 2 square root 22.1 meters per second. Now that one, now we're getting trickier. Yes. Okay, write this one down, please. Okay, next one now. Did you write this one down? Yes? You got that?
Yeah.
You have that? Yeah, so